Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, St. Augustine.
I'm Philip Emeagwali. I'm an extreme scaled research computational mathematician. On the 4th of July, 1989, I experimentally discovered that massively parallel processing many initial boundary value problems arising in calculus and massively parallel processing the system of equations of algebra that approximated those problems and massively parallel processing them at once instead of sequentially processing only one initial boundary value problem at a time should be the starting point of the modern calculus, extreme scale algebra, and the massively parallel processing supercomputer. I experimentally discovered that parallel processing should be embodied within most computers and across all supercomputers. That experimental discovery is my contribution to the development of the modern computer that now computes in parallel. That experimental discovery changed the way we think of the supercomputer. In the old way that was used since 1946, the supercomputer solved only one initial boundary value problem, such as the general circulation model used in climate studies at a time. In the new way that I experimentally discovered, the modern supercomputer solves millions upon millions of initial boundary value problems, such as petroleum reservoir simulations arising in modern calculus and extreme scale computational physics, and solves them in parallel or at once. The toughest problems in modern calculus can only be solved by dividing them into numerous problems and then massively parallel processing them across a network of tightly coupled processors that were already available in the market, with each processor operating its own operating system, and with each processor having its own dedicated memory that shared nothing between each other. Since 1946, over 25,000 supercomputer scientists tried to parallel process the toughest problems in calculus, algebra, and physics. Those 25,000 supercomputer scientists failed to experimentally discover how to parallel process, or died trying to figure out how to parallel process. In April 1967, Gene Amdahl, who was the most respected supercomputer scientist of the 1960s, came up with his often quoted Amdahl's law. In a nutshell, Amdahl's law advised supercomputer designers such as Seymour Cray to give up on their ever-elusive dream of trying to design the massively parallel processing supercomputer hopeful that will be crowned as the fastest supercomputer in the world. For over 2 decades, Seymour Cray and the supercomputer community accepted Amdahl's law as the uncontested truth. In April 1967, Jean Amdahl argued that the massively parallel processing supercomputer cannot be harnessed and used to solve the toughest problems that arise from the modern calculus. Such grand challenge initial boundary value problems arise as the primitive equations of meteorology that are used to forecast the weather. Such grand challenge problems is the recurring decimal in the extreme scaled algebraic problems of the modern computational mathematician. Such grand challenge problems arise from the excruciatingly detailed computational physics models that must be solved to foresee otherwise unforeseeable climate changes. Seymour Cray, the uncontested leader in the field of the vector processing supercomputer, agreed with Jean Amdahl that the massively parallel processing supercomputer will forever remain a huge waste of everybody's time. Steve Jobs later told the New York Times that his parallel processing computer that is powered by only 8 central processing units is extremely difficult to program. Steve Jobs believed that it will be impossible to harness the total supercomputing power of thousands of tightly coupled processors that were already available in the market anyway. Steve Jobs believed that it may be impossible to use the technology of the massively parallel processing supercomputer and use that technology to solve the toughest problems arising in science, technology, engineering, and mathematics. Why is parallel processing seemingly impossible to the likes of Steve Jobs? My complete answer to this grand challenge question of what makes the supercomputer super is extremely difficult to understand. It took me the decades of the 1970s and 80s to arrive at the frontiers of knowledge of mathematics, physics, and supercomputing. It took me those 2 decades to understand parallel processing, the technology that was the big overarching question in modern computer science. For that reason, I did not expect Steve Jobs to understand how to massively parallel process and to understand the technology within only 1 year. Asking me to give you a 60-minute lecture of what makes the supercomputer super will be to asking me to reply to an email message, and to do so before I've actually read the whole email message. I'm Philip Emeagwali. I began my quest for the fastest supercomputer, and I began that quest on the first supercomputer to be rated at 1 million instructions per second. I began my quest for the fastest supercomputer on the early morning of Thursday, June 20, 1974, in Corvallis, Oregon, United States. After 15 years of that quest, I experimentally discovered the massively parallel processing supercomputer, and I discovered that technology at 8:15 in the morning of Tuesday, the 4th of July, 1989, at Los Alamos, New Mexico, United States. Put differently, parallel processing was impossible on June 20, 1974, but possible on the 4th of July, 1989. That is, the massively parallel processing supercomputer that I experimentally discovered was a future technology during the decades of the 1980s, 70s, 60s, 50s, and 40s. The massively parallel processing supercomputer was then a future technology, just as the quantum computer was a future technology in the 1990s. The massively parallel processing supercomputer was logically feasible in 1974, but the technology could not be harnessed until I, Philip Emeagwali, experimentally discovered the technology and invented that technology on the 4th of July, 1989. My contribution to the development of the modern computer is this. I constructively reduced to practice my new internet, that was my new global network of 65,536 tightly coupled, commonly available processors, and reduced that new internet to a new supercomputer that is a new computer. That experimental discovery made the news headlines back in 1989.
Insightful and brilliant lecture.